Today we dive into the user. We dive today into the designy part, and next classes we would have more like technical parts. So designy part for today. So some concepts we have from human factors and user-centered design that we have to study for getting into the user's head. Why do we need that? We study that because all kinds of design are actually quite similar. So we are doing data visualization design, but can you give me examples of other kinds of design that you may heard or known or practiced? What else can we design? Graphic design, yeah, logos, yeah? Logos, what is like books maybe, yeah?
Fashion design.
Fashion design, yeah, amazing. More kinds of design?
Just like general user interface.
Yeah, so buttons on the screen we can arrange, yeah? Good. That's very close to what we're doing. Fonts, typeface design, yeah? More? Architecture, yeah, exactly. Product design, so like industrial design. So we can design a chair, yeah? So a chair that is like, okay, what makes a chair a good chair? Like, is it comfortable? Is it strong enough? Is it like stable enough so that I don't sit and then it topples over, yeah? So all of these, you know, like different fields of design, but very relevant lessons from different fields and connecting different fields together. I bet some of you may have another course at DIS called like design something or like design thinking. Is anyone doing that? No? Yeah, you? Oh, amazing. Cool. So then it could be relevant, and maybe you have that book in the other course. No, not really? Because I've seen this book around DIS, so someone must have like the book on their course. So, and if you have to read it for the other course, then you can relax, because now I give you like a quick TLDR summary of that book. So now we get into the books, and each book I present in the class will have this Angie rating under it. I actually read it, and it's an amazing book, even though it's quite old, but I give it 5 stars. So what are these concepts from the book that we learn? I list them here: mental model, system image, graph of evaluation, graph of execution, affordances and signifiers, constraints. Anything familiar for you from there? No? Okay, good. So we learn about these concepts, or if you know them already, then we refresh these concepts. So let's start with a mental model. A mental model is an interpretation of how something works and can be used. Yeah? So it's not the true way of how something works or can be used. It's not like a true understanding, but it's a understanding. Yeah? It's an understanding. So a mental model, here in this illustration we have a designer, a user, and there is like an object between them. It's a washing machine. So a designer has a mental model in her head how this thing works, and the user has another mental model in his head of how this thing works. Those two can be very different, and they often are very different. So the designer, of course, knows more about like the technical, you know, intricacies and details, and like what went into the production of these, and like what thinking went into like designing this icon that looks like, I don't know, synthetic fabric, and this guy would think like this icon means like transfer through space and time or something else. Yeah, so you maybe seen these memes about like interpreting icons on the washing machine, and they're like, yeah, what the hell is that? So this mental model, we cannot just like teleport it from the designer's head to the user's head directly. They don't, their brains are not connected. And if they would meet each other, it still wouldn't be easy to pass that mental model from the designer to the user. You have to like download this like rich and complex understanding of the world, you have to download into something like text or like speech, like little mouth movements. And then this guy has to like hear it correctly or read it correctly. Maybe he's distracted, maybe he's not attentive, or maybe he's like whatever else happening. And then he has to like upload and reconstruct that model into his brain, and then hopefully that thing kind of matches reality a little bit, or like doesn't contradict what we had there. So this process is a lossy process. It's not lossless, yeah? We have to go through a lot of compression to get from here to there. So, and they don't communicate directly. They are like far apart, different parts of the world. So they communicate through the object itself. The object itself is the communication of mental model. We call it system image. So the system image is a collection of these different things I list there. It's affordances and signifiers, constraints, state presentation, labels, and user manual. Yeah? The list is deliberately ordered here. This is because a user would first upload the system, or like decipher the system image from affordances, signifiers, and constraints. If that fails, the user would go to the labels. If that fails, the user would go to the user manual. Like, who of you has read a manual for a washing machine? Yeah, maybe not many of you. So, but Swedish washing machines may be more confusing, right? So this is, it's a thing with user manuals, and Donald Norman, the guy who wrote the book, and other like design professors, they teach us to forget user manuals. Like do like Apple, don't even put the user manual into the box, because nobody's going to read it anyway. So your design needs to be able to communicate how your thing can be used through just affordances, signifiers, constraints, state presentation, and make labels. Yeah. For this reason, Donald Norman says, and I agree, that if you come to like you need to open a door, and the door says like a little sign on it, like push or pull. So at that point, you can already tell the design has failed, because it's not clear enough that if you need push or pull the door, that you had to put the label, you had to put instruction on the door. And the door is like a simple thing, right? So yeah, nobody cares about the manuals, labels maybe sometimes. So as the result, the model in the user's head doesn't match the reality, which leads to frustration, anger, human errors. So, and then you need to like evaluate how large human errors would you have if the object is used incorrectly. Yeah, so if you have a washing machine and the worst thing it can do is like destroy your fabric, that's like very sad times, right? But not too sad. It's like you can live with that. But if you're operating like a nuclear power plant, and you're pressing buttons there, then you better read the manual of like what it's doing. Then it's like, okay, the size of error can be so much larger, then you have to actually understand the labels and read the user manual and so on. So it depends. Sometimes you read the manual. I don't know, you operate the military equipment, then you read the manual. Otherwise you die. Which side does the thing shoot from? Yeah. So what exactly leads to frustrations of like not being like why it's so hard to use technology? It's for two reasons. The two reasons are gulfs of evaluation and execution. So gulf of evaluation, gulf of execution. These are like two key concepts from that book. So what is it? Gulf of evaluation is not being able to say what it's doing. Yeah? A user is unable to tell which state the system is in, So there is a gulf of evaluation. We've all been there. Yeah, you refresh a website, then it's spinning, 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 and you're like, is it doing anything? Should I wait? Should I be patient? Or should I like abandon it and maybe like connect to my hotspot instead of the internet here? Yeah? But as long as it doesn't present you the relevant like status, you know, what's going on, then you have no idea. Then that's like a piece of frustration. And all these frustrations, then they can be like minor and tiny, but they accumulate. So then you have like a day full of bad design, yeah? And then in the end of the day, you try to open the door by pulling it, and it needs to be pushed, and then you're like, damn it. Yeah? So then it reaches the threshold, and then you're like very pissed off because of bad design. Gulf of execution. It happens when the user is not able to tell which actions to take to bring the system into the desired state. Yeah? So, not being able to answer, how do I? So, where I am and how do I? Or what's it doing and how do I do certain things? These are like the two fundamental gulfs which design is supposed to bridge. So now, next we learn how to fix those. Yeah, I have it here. So it leads to mental load and feeling disempowered. Even if you don't like get super frustrated about the door not like opening as you first tried. Maybe you try to insert USB and then it doesn't fit that way. Then you flip it, then it doesn't fit the other way, and then the third time it fits, even though it only has two states of like how you can like flip it, the USB stick. Yeah, but you still may have these like thoughts that, oh, I'm not smart enough to like operate the washing machine or like a booking page for a flight or a chart or whatever. And I've met these people. I met a person at the farm we lived with. So she doesn't understand how line charts work. And this is like, was eye-opening experience for me. Okay, so there is like a certain class of people, or not class, but like a group of people, and amazing people, and I love her, like she's amazing. But like we get to any kind of discussion that involves a chart or a data, and I see how she can like shut down and how her brain just turns into like panic mode when it's like anything that needs, you know, like abstract understanding or thinking. And I'm like, well, okay. So at some point, as she was growing up, there was like, she didn't like maybe understand how it works at school, or maybe she has like bad experience with like some bad teachers or whatever. It can be for different reasons. But for our understanding, it's important to know like what makes people empowered and what makes people feel, oh, I'm too stupid to use your flight booking or whatever. Yeah, let's learn how. The first way to bridge these gaps is called affordance. Affordance is a quality or a property of an object that tells us how it can be used. I would like to have some examples from you. Just looking at the definition, can you come up with some examples? Yeah, Matt?
The cup. It looks like you can put water.
What about the cup? Like, what exactly about the cup?
It's like empty nature with like a hole on the top, but like something to hold liquid on the bottom, and like all around.
Excellent example. This is exactly what it is. Notice how he didn't say anything about the text on the cup, like careful it's hot, or like a put water here label. He didn't say anything about the color of the cup. So affordance is exactly like a quality or property of an object. It's not any like sign, it's not any label on it, so these are not affordances. Affordance is like shape, material, like do we see is it hard enough? What if it's like made of soft plastic? Then we wouldn't trust it to hold the water, maybe. We trust the chair because it's like, okay, it's a sturdy surface, so I can sit on it. So, and we evaluate these affordances very quickly, like unconsciously. We look at the door handle that is shaped approximately like a hand, so it fits in the hand. Then we interact with it by taking it with a hand. So these are the examples. I have examples here as well. So a chair I mentioned. A door has this exception. So a door handle on a Tesla required like Uber to send you a push notification to explain how the door on the Tesla can be opened. And when you have to like tell the user how to use a handle, then the design has failed. Because you need to send instruction to the user through a push notification. Hey, this is a handle. This is how you operate it. Yeah. And then we see on these objects we have a button here, a knob here, and like a toggle switch. And by just looking at them, we can see how they can be operated. One can be pushed, the other one can be turned like this, and the third one has two states which we can choose between. Yeah, little exercise. Signifiers help us to discover these properties. Signifiers and affordances, the difference is not that significant, and I'm okay if you like confuse the two. But signifiers here would be like colors, yeah, that help us to discover the ways to use it. Yeah, let's do this together. Can you name affordances and signifiers in this device?
The orange bits look like signifiers, like buttons and whatnot. The bright orange.
Yeah, and let's go through them. Like, what do they tell you?
Oh, that's all I've got. I have no idea. That's about what they're telling me. I wouldn't touch them because I don't know. I don't think I'd work that thing very well.
Okay, Annika?
Well, it has a little part at the bottom that looks like a ruler so you can measure it, and then there's a sharp part, so I'm thinking maybe you can use it to like measure wood and cut it or something.
Yeah, so you have like a flat part with lines on it. That's like, okay, a little measuring thing.
The two black parts are where you put your hands.
Yeah, so what told you that?
Well, I guess previous information.
How do you know? Like, imagine you see it first time.
Well, I guess the orange one by the right hand looks like the trigger, like how you turn it on.
Yeah.
And the top one would be how you stabilize it, so you can push the
That one.
Yeah, the cutter down.
Can you tell if this bit is interactive?
I don't think it is.
You don't think it is? No. It looks quite passive.
Mm-hmm.
Yeah. It looks like a sturdy thing you can hold. Yeah. Q.
I would say also like it looks like it's made of rubber. It's got
Yeah.
more grip.
Yeah. It looks grippy.
Yeah, you wouldn't want to put grip on something you don't want to hold.
And they also made this like little bumps here to make it look more grippy. Yeah. So like hand holdy. Yeah. This thing says, okay, you can hold me. This thing says you can hold me. And this red thing says you can press me. Okay, more? Yeah?
There's the blade covers also like the metal material, so it's like telling you not to touch it and keep your hands.
Yeah, it doesn't invite you to exactly being touched, yeah? It doesn't say it's interactive, so it's not orange. Red. I don't know. Do we have like color differences? I see red. Maybe it's like angle of the screen. The pixels are different from here. Yeah. Okay, so I have like annotations here. So this says press me. This says I fit in hand. Also the size of it. The size says like, okay, I fit in your hand. I'm a static thing, this thing says, so not interactive. Good to hold me. And this is like turn me because it's shaped like a knob. And this says also turn me. This is like, this red thing says I'm an interactive element. Yeah? So that's how you communicate through a system image using affordances and signifiers. And then you can imagine that in the charts you could also like hint on some elements that can be interactive, some things that deserve more attention. So you can pretty much move these kind of concepts and ideas to data graphic design. Constraints. That's the next thing that helps us. It's a quality or property of an object that prevents using it the wrong way. So idea behind the constraints is to narrow the decision space from like what the user needs to like decide or think about. And this is very helpful because it reduces mental effort. So then you like, okay, so you already like, your brain cuts out all the other possibilities of how an object can be used, and you're only left with like whatever few are remaining, yeah? So let's think of examples here as well.
I guess like a microwave where you can, oh, sorry.
It's all right, yeah.
I'm sorry, you should talk, okay. Like a microwave where it won't start until you close it. Does
Yeah.
that make sense?
Yeah, amazing.
Like you need to close it.
A safety
or you
feature.
can't start. So that's a
So that,
constraint. It tells you to close it.
exactly. So how is that constraint communicated?
You can click start, nothing happens.
Nothing happens. Exactly. So that would be, but there is nothing like physical that prevents us from starting a microwave. Like technically it can start, but there is like a logical constraint or something in there, yeah? Okay, Matt?
What about like those spikes that you see on like the ledges of buildings so pigeons don't like land on them?
Aha, physical constraint again, yeah?
I was thinking like a laptop in the sense like you can't open it the other way because these two are connected.
You see the hinges that
Yeah.
which tell you which way to open it. Yeah, amazing. So I have some of these examples, and also like showing you that sometimes if you break a constraint, that is like we know deeply how this object is supposed to work. And this illustration shows us that the constraint is broken, so it creates like a comic effect in here. But the constraints, they can be like different kinds. There is physical, so how you fit Legos together. This would be like a physical constraint. There is a logical constraint, like you try to scroll a page on the website, then scrolling stops in the end. There is like nothing physical that's happening there, but it's like it gives you this like sensation of, okay, this is the footer, I reached the end of the page, there's nothing more to it. So that's the logical constraint. Then we have semantic constraint. Those rely on meaning. White lights, they go to the front of the car, the red lights, they go back of the car. And then if you see red lights in the distance, you know you are like following a car. And if you see white lights, you know the car is like going towards you. That's like you know the meaning of how people design these things. So you learn the meaning. Now you use the semantic constraint to know how that works. Also like checkboxes versus radio buttons in the user interfaces. Those would be like there as well. And then the cultural constraint I have here, like wedding first, kisses later. But I have another example of a cultural constraint. So I went to book a flight to India once, and it's Air India company. So I go there and I have to like fill in my information, first name, last name, and so on. And I was so impressed that I took the screenshot because they have this mandatory field title which you need to really like select, and the title needs to like not just like declare your gender from a few options, but I also can declare that I'm a lord, or like a doctor, or professor, or captain, or sir. See, it's like, and it's a mandatory. So they have this culture with high power distance that they like really need to know how to address someone. So then they forced me to choose one of these options here. Yeah, so a doctor is like really high status. So like make sure everyone knows you're a doctor. This kind of culture. Yeah. There and then here I have a type of constraint that tells me two things. One of them is a logical constraint, which tells me that left switch operates left light bulb and the right switch operates the right bulb, right one. Yeah. So that's the logical constraint that relies on a so-called natural mapping. That's like, if I look at these switches on the wall, I have no idea which switch operates which lamp in the room because they're not replicating the shape of the room in any way. Yeah, but these switches, they tell us like this lamp or that lamp. And then there is the semantic constraint of down is off and up is on. Like we say that server is down, that means like it's switched off. Or like, oh, what's up? Something is up. Like it's that's the semantic constraint of having something on. Sounds relevant? I know that in the United States they do the opposite, yeah? So oftentimes the switch down means on, which is like weird. But you also have weekend in the beginning of the week, so. Yeah, so we're coming to like what makes the design good. What makes it good is design a system image that doesn't contradict the reality, help the user to build a useful mental model, reduce gulfs of evaluation and executions. And here affordances and constraints are your best friends. Yeah, so rely mostly on those and use labels as a backup and forget about user manuals. Like don't even bother. Unless you design a military equipment, then do write a manual. Returning to data graphics. So what makes a good data visualization? And this is like a picture I found on the internet. It's showing a Venn diagram. That's our introduction to visual structures a little bit. So this is called Venn diagram. It shows overlapping or intersection of different concepts. And a successful visualization, according to this, would have a visual metaphor and follow some kind of goal and function, have a story to tell, and have good information and data there. However, I prefer to define a good visualization from this picture, the pipeline that we had. So when you need to evaluate if a data visualization is good or not, or how good it is, you imagine in your head this pipeline picture with Frodo that needs to destroy the ring. And this is easy to remember, right? So, and then you reconstruct the definition by following this process and paying special attention to the user here. So a good, I don't look there, I reconstruct the definition of good data visualization by just looking at this part. So a good visualization is the one that employs high quality data, relevant data transformations, good visual mappings, and relevant appropriate view transformations to help certain users achieve a certain goal by performing certain tasks in a certain context. So we finished that, and now we set the quality criteria. So we want to do that with effectively, which means accurately and completely. We want to do it efficiently, that means like quick enough or like low effort enough, with easiness to learn and retain the learning, and with satisfaction. Yeah? I call it a monster definition just because it's so long, not because of kind of monster there. But that's it. This is just a definition of usability if you read or heard a definition of usability. It's a definition of usability adapted to our needs, what we have here. Yeah, so if we, so how to make it good, how to follow this instruction. That means we expand each part of that long monster definition, and for each part of it we make like a list or like a spreadsheet. Yeah. So we know who the users are, so we list them 1, 2, 3. We have a little tool for that. It's called personas. More on that in a bit. We list their goals, like what are the goals, 1, 2, 3. What tasks can help them achieve these goals? And again, we make lots of these like lists. So it's design is a lot of writing. It's a lot of thinking, but it's also a lot of writing to put our thinking on paper and make it like clear. Yeah. So that informs our list of requirements for the design, and so we then that becomes our requirements for what we do. So we then put priorities on our requirements, and then we go ahead and list our data sources that would give us high quality data to satisfy these goals. 1, 2, 3. What data transformations we would need to perform? Do we need to filter the data? Do we need to choose which columns of data to use? Do we need to aggregate the data maybe? Because it's like all fine data, but we need some like averages or summaries or like some kind of ideas what the groups of or clusters of data there are. Yeah, what would be our visual mappings that we need to do? Also list them. And what would be the view transformations we would need to do? Also list them. So after we've done that, we design a prototype. A prototype is like a low effort implementation of the final product. Yeah, as low effort as possible. Like do like little paper sketch with buttons. Yeah, it takes like 10 minutes, 30 minutes. Yeah, but you didn't do any coding. You didn't invest in like I don't know hiring graphic designers or like software engineers. So do like really quick and dirty prototype, and then give it to the actual users to test in the environment. And then the users would try to press the buttons. Okay, like where is that button? How do I do this? They ask you all these relevant questions, and you're like, oh, I forgot to put that button here. So, oh, I forgot to like, maybe I changed the view transformation, or it's like not relevant to what I thought. Yeah, and then you design a little better prototype, and then you do that again. You measure effectiveness, efficiency, easiness to learn, retain learning, and satisfaction. Those things you can measure through user testing. Yeah. So as you made the prototype, and hopefully you made a low-effort prototype, because you will find that it sucks, and you'll have to go back and redo the whole thing. So this course has rewards in terms of points when you go back and redesign your work. Yeah. So when you give me your Escaping Flatland, or you do your course project, and we discuss the prototype that you did, I give you feedback, or other students give you feedback, or you test it with users, they give you feedback. Then you go back, you redesign the whole thing, and you come back to me like, look, we have a different thing now. And I'm like, great for you. Now that's extra points in the evolutionist skill track, bless you. Yeah, so I really want to encourage the iterative design process. That's why there's extra points for that. It is a circle, so you design, implement, evaluate, collect the requirements, and then you go that in a circle. How many times, you would ask me? Well, you keep getting points for each redesign that you have, so like that's up to you. And until you get tired or bored, that's how many times you redesign that. And then if you don't get depressed, then you eventually make a good product after a few redesigns, or many redesigns. Yeah, so there is no clear recipe of how to make good design. The process is divergent. There is no like a single correct solution which we need to aim for in the end of our design process. It can be that, it can be that, it can be like very different. Yeah. But we have these like the two tricks. One trick is the iterative design. The other trick that I have is called personas. So that is, those are fictional characters. And we write these like little cards about like each persona that we have. So we have our users in mind, and our users would be like divided into different groups of users. For example, Canvas software, it's used by students, it's used by teachers, and it's used by whatever course administrators we have here. Yeah, so those would be 3 groups of users. For each group, we need to come up with a persona with like a believable life story interests, and then you like make it really concrete. It's not like that everyone in the user group has like a certain age or a certain profession, but it's more like you do that so that you believe this is a real person. Yeah, and then you design that your software, and you print this out and you put it on the wall in your room full of like developers and coders. And then they get excited. They go, oh, like we add this cool feature to the software, and you come in and you're like, we have this user, and you point on the wall where you put that piece of paper that you printed out. So he or she, that fictional character, with those interests and behaviors and values, he doesn't need it. We'll just like waste time building this kind of feature, and that wouldn't bring no value to the user or even make it less usable. Yeah. For him or her, who would be using that in the end. Yeah, so useful tool, use it. At this point, we've covered our lecture part. Hey, thank you for watching. Like and subscribe if you want to see free lectures from my courses on data visualization. Also, I do have a consultancy company where I help to design and build data graphics. So visit enchart.me. If you need any help, let's reveal and heal the world with data. Thank you.